One great algorithm for being able to predict what is going to happen is multiple linear regression. In this video, I will work you through an example of how to do multiple linear regression to create a predictor. In this video, you can assume that we are creating a weight loss predictor for people that want to lose weight. And assume that we have the percentage of time that someone stays on their diet, the amount of exercise they have accomplished per month, and then the amount of weight they lost during that month. So an example of this might be if you're working for Jenny Craig or some organization like that that helps people with weight loss. And you would like to be able to say, depending on percentage of time that someone stays on their diet and the number of exercise hours they have in a month, what kind of weight loss could they expect? And so you would want to be able to take historical data on actual people, and you'd want to be able to create predictors so that you could basically plug in any amount of percentage of diet adherence or exercise hours and be able to come up with a pretty close estimate in terms of how much weight someone would lose. So usually when we're doing something like this, it's a good idea to first look and see what the correlations are between these data, because if there's a linear relationship between these data, it's usually a pretty good indication that we're going to be able to make a prediction. So we'll go into our data analysis and we'll run a correlation on these to be able to determine how well this information is correlated. And so we'll do that. So here's the resulting correlation table. We can see that there's a high degree of linear relationship between the percentage of someone's diet and their weight loss, and also the amount of exercise hours that they put in a month on their weight loss. So this gives us a pretty good idea that we can expect to be able to create a linear model that would be able to predict how much someone would lose based on this information. If these were very low correlations like 0.03 or 0.05, then we would really worry that we're not likely to be able to create a good predictive model. So back at this sheet where we have our input data, we would like to be able to let the algorithm be able to figure out what the relationship is between exercise and diet and weight loss. We'd like to have a model that will take these inputs and then predict what the weight loss should be from actual people's experience. And then we'll be able to predict how much weight loss the model says we should have, and we can compare that to the actual weight loss, and then any difference will be the residual, the unexplained portion. And then we can take that residual and translate that into a percentage difference. In other words, what percentage are we off from the actual weight loss? So we'll go to our data tab and back into our data analysis, and we will pick regression. For our input range, for Y, we want our weight loss. And for our predictors, we want to have our diet adherence and exercise hours. Our labels are on our first page, and put it on a new tab. We're also going to click Residuals, because by clicking Residuals, we'll be able to have it calculate automatically what the residual value is, which is the difference between the actual value of weight loss and what our model predicts that will be. Okay, so here is our results. Right now we have a very high R-squared, about 80%, 86% of the variability in the Y or weight loss is predicted by the model and the data that we have in the model. We are very statistically significant. This is an infinitesimal number, a very teeny number, which tells us that the likelihood that this model is a fluke is completely remote. It's very unlikely that this is not a systematic model. If we look down here, we can also see the probabilities for each one of these coefficients. And we can see that the intercept is about a 15% chance that it is that this intercept value coefficient is a fluke or is not systematic. But we can see that in terms of diet percent and exercise hours, these are also very, very small numbers. And so there are very low probabilities that these numbers are flukes, or that these are not systematic. So we can see that we're very confident about these numbers. So what do we do? So I'm going to reformat these numbers a little bit just so that they have less significant digits to look at, just to make them a little bit easier to see. So, and then these are redundant, so I'm going to get rid of these out here on the end. So how do we interpret this data? Well, these are statistically significant. So what this means is these coefficients mean that in terms of using an equation, then we would predict weight loss as this. Y being weight loss equals the intercept, which is 1.66, plus the diet percent, which is this value, which is 17.9, times whatever their diet percentage is, plus this value, 0.0846, multiplied by the exercise hours that an individual has, and so this is basically our regression model, our linear model that will let us predict what the predicted weight or the predicted weight loss is going to be. So to make this easy to plug in, what we could do is, let's take these coefficients back over to our data page. So those are our coefficients, and what we want to do is we want to take and calculate our weight loss. And so what our weight loss will be is we're going to take the intercept plus the diet percent, or excuse me, plus this coefficient for diet percent times the actual person's diet percent plus the exercise hours coefficient times the exercise hours of the individual. So what this tells us here is that if a person stays on their diet 25% of the time, then we would expect them to, but they're not really exercising, we would expect them to lose 6.1 pounds. Now to be able to copy this down, before we copy this down, we need to anchor in these values so that we don't have things sliding off as we do it. So we're going to go over here and we're going to hit F4 and anchor each one of these. That way, as we copy this formula down, it will stay linked to these cells and will not tend to just slide off like a window of sliding off. All right, so we can see that if someone stays on their diet 100% of the time and they exercise 30 hours a month, which is about an hour a day, they can lose up to 45 pounds. So this must be a pretty tough diet to be able to do that. And we can see what I did is I created these numbers sort of as a sensitivity analysis, because I created some where people stayed on their diet of varying percentages of the time and no exercise. So we would expect about 19 pounds of weight to be lost if they just stayed on their diet. And then here people are not staying on their diet, but this is the amount of hours they're exercising, and you can see the weight loss here. And then here I put together some percentage of diet adherence and then the amount of hours, and you can see that we have that. So it's a very good way of being able to get a feeling for what people would expect to be able to lose based on this. Our first predictive model here, or we just created a predictive model. Now, if you look below the regression results, it also, because I clicked residuals, it also calculates the residuals down here. So this is actually what our models, it's not actual, this is the predicted weight loss for each observation. So this is person number 1, person number 2, and of course each one of these had their own diet adherence and the number of hours exercised work. So the residual is the difference between what our model predicted and what the person really lost in their weight. And so as you look at these residuals, you can see that some of these were very close. This one we were off by about 6 pounds, but often we're very close. We're within a few pounds and sometimes even less than a pound in terms of our estimate. So if we take these now, if we take these values of the predictions for each of these observations and the residual, we can paste them in. And what this will do is, so here's an example. For this first person, we can see that their predicted weight loss was 33. Their actual weight loss was 30 pounds. The difference was about 3 pounds. And if we translate that into a percentage of, this actual, then we can see a percentage of they were off in terms of absolute value. So what I did in this formula is I took the absolute value of this residual and then divided this into it so we could see what percentage they were off. And it didn't matter whether they were over or under. It just matters how far off they are as a percentage. And then I took the average of all those values. And you can see that, we're usually very close. We're 10% or so. And you can see the average down here, the mean absolute error percent is about 14%. So overall, we're usually within about 14% of our actual values. Sometimes it's less, sometimes it's more, but on average we're about 14% for actual. So then we can take any value of diet within this sort of like a reasonable upper and lower bound. We can take any value for diet and exercise hours and be able to tell how many pounds a person would be expected to lose.